Hello, and welcome to another openFrameworks audio programming tutorial. Today we will be discussing panning, something that should be simple but is not. First, we will do it the wrong way and discuss why this is wrong. Let's start where we left off in the last tutorial. If you are not following along sequentially with the series, visit the description in the last tutorial for the code. Alright, so we're going to need a couple variables. Remember that we assigned the left channel of audio here and the right channel here. So to make a panner, we're going to need a scalar value to scale the left and the right proportionally. So let's make float left channel scale, float right channel scale. Alright, first we're going to map this left and right with the mouse X position. So we will need to get rid of some stuff we have here from the previous tutorial. We will no longer be able to map frequency to the mouse X position. Okay, so let's do it the most simple way first. We'll set left channel scale equal to map of the X position 0 to the screen width, and we'll go from 0 to 1. And for the right channel, we'll do the same thing. Actually, we'll copy and paste that. But this time we'll take the inverse. So 1 minus 0 to 1. Now, when this is 0, this should be 1. And when this is 1, this should be 0. And if they're both in the middle, they should both be 0.5 if the math is correct. So let's scale this value of our current sample going to the left channel. And the current value going to our right channel. Now it should be up and running. Seems to be working well enough, at least. I did mix that up and I did that backwards. So let's go down here and just switch these two around, and that will solve our problems. Okay. Let's go ahead and check if that works, which it will. Alright, we have success. Okay, so the next step you see often in panners is to, instead of taking these linear values, we take the square root of that value. This will help fix the dip in the middle. Let's listen to that again. And when we're in the middle, the sound's a little more faint. We want to get rid of that. This will be more clear if we get rid of the change of amplitude from our Y position. The difference is especially clear when using speakers instead of headphones. Alright, so let's take the square root of these values. And see what kind of difference that makes. If you think about the math here, The square root of 1 is still 1, and the square root of 0 is still 0. We do get a curve along the way. Alright, so that's better, a little more expensive. We have to call, later on when we build a panner, we'll have to call a square root function every single sample of audio, which is fine if we're only doing that once, but if you have a 100 channel or 100 polyphony synth going, that's going to cause some problems. But first, before we make it more efficient, let's make it less efficient, but what I have found to be the ultimate solution. Alright, so let's not map this twice because that might be a little confusing. Make a value called scaled x, and that'll be map, the same thing we had before, map x from 0 to the screen width, and then 0 to 1. Alright, so now we can get rid of this map function and make our code a little more easy to read. Alright, so that's what we had before. Let's do something new. And instead of taking this from 0 to 1 like we are here, let's take it from -1 to 1. This will be convenient later on as we can use a simple oscillator as our panner. Before we get to that, let's make our new equation. This is my favorite. This equation can be found in the computer music tutorial by Curtis Rhodes on page 460 if I'm not mistaken. But let's do this the expensive way first. Square root of 2 divided by float 2 times sine of theta plus the cosine of theta. And in the right channel we'll have nearly the same thing. Square root of 2 divided by 2 times sine of theta minus cosine theta. Only difference is that we're subtracting the cosine of theta instead of adding. Right? We don't have theta yet. Theta needs to be in the range of -45 degrees to 45 degrees. So it's easy to get -1 to 1 to -45 to 45. Scaled x times equals 45. So -1 times 45 is -45. 1 times 45 is 45. Alright, we're not there quite yet. This is in degrees. We actually will need radians. So we have a simple function in openFrameworks. Scaled x equals of degree to radians scaled x. Alright, so now we should have -45 degrees in radians instead to 45 degrees, or in radians instead. Alright, and let's make this theta. Alright, so now we should be good to go. Okay, and I once again forgot to reverse those. Great, so now we have a panner. We are panning this and getting scalar values based on some pretty heavy math. This is even worse than the last method because we have to call square root twice, divide twice, take the sine of the same number twice, take the cosine of the same number twice. So we're being pretty inefficient here, but for the sake of clarity, let's leave that alone. Okay, this is great, but this is not exactly portable. We want to build a panner where we can just give it an input and a pan position and it returns our current frame. So let's build that in our audioTools header. Previously we stored our oscillator here. We can store multiple classes in the same file. So let's make a new class. Call it panner. Make our public variables and our private variables. Alright. So our panner needs to return a frame of audio. There are a number of ways to go about this. I promise to keep pointers out of our life until we absolutely need them. So let's avoid using pointers. Instead, let's make a structure called a stereo frame. A structure and a class, as I've said before, are nearly identical. The difference is, if I don't write these in a class, everything's automatically private if I don't tell it not to be. Whereas in a structure, everything's automatically public. And that's a key difference. However, as I said last time, there's kind of a historical context and ways to use structure in a class. And we're going to follow that today. So we'll just store data in our structure. Let's store a left sample. And we'll store a right sample. Great, and it should turn green if it's happy with everything. I'm sure it will eventually. Okay, so now we need a function that returns a stereo frame when given our monophonic current sample and a stereo position. And we will want to set that stereo position up to be -1 to 1, -1 being the left channel, 1 being the right channel. Okay, so we need to return a stereo frame. So we need a function returning a stereo frame. Pan. Okay, so this pan will need an input and it will need a position. Very good, and we have gotten rid of our public, so we need to add that. Great. And it's not turning green for me, but that does not mean it's wrong. So there you go. I'm not sure why it's not, but oh well. Okay, so let's copy this. Go to our audioTools.cpp and add this to the bottom. Stereo frame of our panner. The function is called pan, float input, float position. And then we have our code here. Everything's happy, look at that. Okay, so we know we're going to return a stereo frame structure, which is just a collection of our left sample and our right sample. We could easily store that in an array, but we'll avoid that for now, and I think the structure will actually be more clear. So let's make a temporary structure, current frame instead of current sample, and we know at the end we will need to return that. Great. So as I said before, we were expecting -1 to 1 as a position input. So let's go ahead and make sure that if the user who uses this class does not give us that, it'll correct that for us. So if position is greater than 1, position equals 1. Alright, so we haven't used an if statement yet, but it's pretty self-explanatory. If this happens, if this is true, do this. Alright, so if position less than -1, position equals -1. Same thing here, if this is true, do this. Great. And a lot of the times, I won't do that yet just because this is slightly more clear for beginners. Oops. I like to write really short if statements on one line. It makes it a little more clear to me, or not more clear, but I don't need it to take up 3 lines to do something so simple. But for now, let's take up space. Taking up space doesn't take up any extra CPU, so let's just aim for clarity. Alright, so we already have the code to give us the scalar values. So we have our current frame, access the left sample of that frame equals some math. It'll be our input times all that stuff we had. Alright, and let's go ahead and add that. Square root of 2 divided by float 2 times sine theta plus cosine of theta. Current frame dot right sample equals input, same thing, and matter of fact, oh, nearly the same thing, I should say. The only difference is a minus sign. Okay, so as we did before, we'll have to take our values for position and translate them to negative 45 degrees to 45 degrees. So position, let's go ahead and make theta equals position times 45. Theta equals of degree to radians. Of stands for openFrameworks, by the way. If a function in openFrameworks begins in of, you can pretty much bet that it is an openFrameworks specific function. Of degree to radians, theta. Alright, and if you spell theta right, everything should be good. Alright, so a lot just happened. We are making a blank current frame, which will store a left sample and a right sample. We are making sure the position doesn't go out of bounds. We are multiplying that position by 45 to get it to the degrees we want, and then converting from degrees to radians. And then using Curtis Rhodes' lovely math here. Don't have to understand it, we can just use it. Okay, so that should work. And let's get rid of some extra space. Alright, so we called that object a panner. We've already included that extra document, so we should be able to write panner, and that class should turn green. Great. And we can call this panner twice. Let's not, to avoid confusion. A panner, sure. So this is the recipe, this is the result. Okay, so let's go ahead and pan our synth using our new convenient object. So let's get rid of this for now, and all of this. Okay, so we want to use our current sample as our monophonic input. So we need a frame to pass on to the buffer. So let's go ahead and make stereo frame current frame. And notice I didn't point this out last time. I can use the same variable name since I'm not inside of that class any longer. I'm inside of a different class, or openFrameworks class, or application class, I should say. So this is fair game. It won't get confused with the exactly similar name of the current frame here. Sorry, here. So that's fair. And actually one of the benefits of using a class. Okay, so we have our current frame, and at the end of all of this, instead of passing our current sample twice, we want to pass the current frame left sample and the current frame right sample. So now we are going to give different information to the left and right channels. Alright, so we could set our current frame equal to 0, but that won't be necessary. In fact, it wasn't necessary to do here, but oh well. Oh yes, it was, because we used plus equal. Anyway, so let's go to our panner. A panner, or actually let's use our current frame equals our panner dot pan, our input, which is our monophonic input of our current sample, and position, which we have nothing for position yet, but let's go ahead and use the keyword position. Alright, so it's complaining that it doesn't know what position is, and that is totally fair because I don't either. Let's make a new variable, a float, called position. We'll start with the position at 0. And then as we move the mouse, we'll set it equal to the mouse. So position equals of map, openFrameworks map, x 0 to screen width to -1, as I said before, and 1. All right, and it's important to know that of map returns a float, and if you didn't know that, our position is a float, so we'd like it to return a float. We can check here, and if I move my mouse, you won't be able to see it anymore, but the very first word that comes up is float. This is showing us the function definition, and you can see of map does return a float, which is what we want, and we've been using it that way before. All right, so here we go. Positions mapped. Changing the frame based on that position using the panner we made and passing that frame to the audio buffer. Let's see if it works. Okay, and let's go ahead and fix it. This is probably the third time I've done that backwards. I did this equation from memory, and I probably just mixed those two around. So let's go ahead and do it again. It'll work this time. Hey, we have success. Okay, now we have a panner and our bag of tools here, our audio tools. All right, so there's a couple things we can do. This is an unacceptable level of calculations. Fixing that would make our code a little less clear to a beginner, and to myself as well. But there are a couple things I think we can do to make this a little more efficient. We do call square root of 2 divided by float 2 twice. We shouldn't ever have to really call that because this will never change based on any scenario using this class. Okay, so let's go ahead and copy that. Go to our header file, make a private variable. We will not need this outside. It's complaining about private. I'm not sure. There we go. All right, and let's make our, we'll just call it float constant, and we'll set it equal to that. It seems to be okay with this. So let's grab our constant and replace these. Not bad. Okay, so now we don't have to calculate that every frame like we were doing. We only have to calculate it once when we use the class. All right, and every frame we are calculating the sine of theta and the cosine of theta. We will have to get this information at least once per frame, assuming that we're changing positions. So let's go ahead and make something here. Let's be creative and call it sine theta equals sine of theta. All right, and let's replace our sine thetas with that. All right, so now instead of calculating that twice, which is actually trigonometric functions are very expensive. We're saving a lot here. We only have to calculate that one time per frame. Let's do the same thing for cosine. Alright, so we haven't made it really any more difficult to understand. We've just separated it out, so we only have to do a calculation when we have to. Additionally, if this position isn't changing, we do not need to recalculate this. We only need to take that times input. So we could get rid of an additional multiplication and subtraction and addition if the position's not changing, but that'll make our code a little less clear, and just keep that in mind. And ideally, we won't have to call sine and cosine every time at all. What we could have done, and I might change this, I probably won't make a video on this, is store all the values that we'll need in a table and interpolate between those values as needed. Linear interpolation costs a lot less than calling these trigonometric functions. However, this isn't so bad, and I think it's relatively clear. So let's leave it like that, make sure it still works. Cool, so there we have a fairly efficient panner. Not as good as it could be, but I think it works really well. Something that is probably annoying is that we have this tearing sound. To get rid of that, well, first of all, let's talk about why that's there. There's a couple reasons. If I move my mouse really slow, you probably won't hear it. The reason being, well, when it does happen, we've changed the amplitude almost instantaneously, or one sample away, and the audio has to make a quick jump, which makes that high frequency clicking sound. So we will need a way to smooth our position value instead of taking the mouse input directly. And that will be the topic of our next tutorial. So a good project, if you want to move something on your own, is to build the same synth, but move, well, one last thing, I almost forgot. Let's go ahead and make an auto panner. So let's use our sine wave that we've created before. Oscillator, auto pan. So we'll make a new sine wave. Set up that sine wave like we did the others. We need to give it a frequency. Let's give it 1 hertz, 1 cycle per second. Let's do phase, doesn't really matter. Amplitude, let's just do full scale, so it'll go all the way to the right and all the way to the left. If we did half scale, it would only pan halfway, either direction, and the sample rate. And this is our panner, so let's copy that. And instead of position from the mouse, we'll get position from our auto panner. We'll get the sample from that oscillator. Alright, so now when this runs, it should automatically go left, right, 1 time per second, 1 cycle per second. Okay, now we have an auto panner. And now for some exercises, you could try to build the same oscillator and instead of panning the entirety of the oscillator, pan each individual harmonic automatically. So next time we will be smoothing our data so we don't get those nasty tears. See you then.